like the convex lens, there are certain rules uh, for the concave lens also. Okay, how the reflection of light will take place. So now first rule is this. Now first see the diagram. See the diagram. Azaan, getting my voice clearly?
Yes, sir.
So now see here. In this diagram, this is the concave lens. Already, we already know this is the concave lens. This is the principal axis, and here this is the optical center. So a light ray, this light ray is parallel to this principal axis is coming. This light ray is coming from some object, you can say, and entering to the lens, and after entering to the lens means as a light ray enters to the material of the lens, the refraction will take place. From here, this light is refracted like this. This light is refracted like this. So as earlier we have done, so what we have, we will do, we will just produce this ray, this is the ray after the refraction in the backward direction. When we produce this ray in the backward direction, this ray will touch the principal axis at focus. So it is looking like that. When you will see this ray, it is looking like that this ray, no, this ray is coming from the focus. Okay, this ray is appearing to be coming from the focus. So for first rule is a ray of light which is parallel to the principal axis of concave lens, parallel to the principal axis of the concave lens, appears to be coming from its focus, appears to be coming from its focus. See, this is the focus, and this ray of light is coming from the focus, appears to be coming from the focus after the refraction through the lens. Okay, so you can see in this figure also. So this is your rule number 1. Simple rules are there, like the concave convex lens we have studied. So now rules for the concave lens. So see the second part, means second rule. Now focus here, focus on this diagram. So this rule is same as that of convex lens. Whenever a ray of light will pass from the optical center, it will go straight. So this is the rule number 2. A ray of light passing through the optical center of a concave lens goes straight after passing through the lens. In a lens. I'm not wasting time in this. So rule number 3 now. See here, see this diagram now. Suppose a ray of light is coming like this. A ray of light is coming like this. It is appearing that this light ray will going to the focus. Okay, will going towards the focus. Okay, but what will happen? The light ray will come like this, like this, like this, and here the refraction will take place. And whenever the light ray will appear to be coming towards the focus of the concave lens, and again it will become parallel after the refraction. Okay, it will become parallel after the refraction. So this is the focus, and I have told you there are two foci of lens in case of lens. So one focus is this and another focus is this. So 3 rules are there for the concave lens also. So in exam, the examiner can ask you write the rules for the image formation for the concave lens, or simply will give a question like this. Like this means what will happen when a ray will pass from the optical center of a concave lens this time. So accordingly, you have to write the answer. So first note it down. Then I will move forward. Note down this and draw this diagram also. There are the three rules for the concave lens also. When completed, you can ask me to scroll down.
Yes, I can scroll down. Sir, can you scroll down?
Okay, scroll down now. Well, your voice is cracking. You can write in the chat box. Azaan, is your mic okay today?
Yes, sir.
I think either your mic is not okay or your internet connection. Okay, when completed, please ask me to scroll down. Note it down. Azaan, is your internet connection is okay today? So, what about your mic? Is your mic working? If your mic is okay, then you can speak with your mic. Okay, just write this rule number 3. Written. Just write this. When completed, please tell me. Now, suppose you have the concave lens and you have the object and you are placing the object in front of the concave lens. So, suppose this is your concave lens. You can suppose this as a concave lens. Your object is here. So, no matter where you are placing your object, here, always your image will form in between the lens and the focus, and the size of the image will be diminished. Diminished means smaller than the object, and also the image will be erect and virtual. So, write this statement. No matter where your object is placed in front of the concave lens, the concave lens always forms a virtual erect and diminished image of the object. So when your object can be placed anywhere in between the lens and the infinite. Okay. So there are only two possibilities of object. One possibility of object, you can place the object between the center of the curvature and the infinity. And another possibility, at the object itself at infinite or infinity. Okay. You can place the object in front of the concave lens between optical center and infinity, or either at infinity. Just copy this also. And then you can just write D. Okay, instead of done sir, you can write just D. I will understand that you have already written that. Okay. So yeah. So now we will discuss the image formation by the. So your heading is this: formation of images by the concave lens. And first possibility of object to place is we will place the object in between the optical center and the infinite. So I am taking a lens. This is my which lens? Concave lens. This is my concave lens, and this is a central line, you can say, and this is the principal axis. And this point is the optical center. And suppose your object is here this time. Concentrate on the screen. This is your optical center, and this is your concave lens, and this is your principal axis. And you have placed the object here. You have placed the object in between this optical center. O is the optical center, and anywhere means you can put here, anywhere between the optical center and the infinite. Infinite is a very large distance. So suppose your object is here. This is your object. Now we have to draw the ray diagram to form for the formation of the image of this object. So what we will do the same things. The ray of light for the image formation, two rays are required from the object. First ray will be like this from the object, and another ray from the object will be like this. And this ray, first ray from the object is like this, and another ray from the object will be like this. And first ray is parallel. So if a ray is parallel, so what will happen? You can see here. If a ray is parallel initially, it will appear to coming from the focus after the reflection. This will be the condition. Na? So here I can just so ray is coming like this, and from here the reflection will take place. And when you will produce, this is the refractative, when you will produce this ray in the backward direction, when you will produce this, so so earlier what you have done, this is the ray produced. Okay. So now I think you can understand. This ray is parallel, and from the lens after refraction, this ray will go like this, and we have just produced this ray in the backward direction. And according to the rules for the concave lens, so this ray will meet at focus. Okay. And this ray, another ray from this object will go to the optical center, and it will go straight. Okay, and here both the rays will meet, so here the image will form. The image will form here. So this is the image. This is the image. This is your object. This is your image. So Azaan, is this image larger than the object or smaller than the object? What can you say about the image? Real or virtual?
So smaller than the object.
Like your mic is not working actually. Okay, no problem. So we already know that you can put the object anywhere is smaller than the object. Very good. Always the convex lens will produce the image virtual and erect. And we can also see from the diagram also. So nature of the image will be virtual and erect. Size of the image, if we will talk about, then size will be smaller than object, or you can say diminished. Diminished means smaller than object. And position, you can see the position, the images in between focus and optical center. So you can write between focus and optical center. Between F for focus, or you can write this as F dash. Not F dash. You can write just F. You can write focus and optical. So this is all about the image. This diagram I have taken just to give you the practical understanding. Suppose you have a concave lens and you are just watching this comb, okay, by the concave lens. So after when you will look through the lens, the image of this comb will be smaller, okay. So an object is this, na, and image is this, and this is a concave lens. So you can see here also the image is smaller than the object, and this image will be virtual also, and this image will be in between focus and the optical center. This is our first case. The second case is very simple. Means when you will place your object at infinite, when you will place your object at infinite in front of the concave lens. Means suppose this is your concave lens and your object is at infinite. Infinite is a very large distance. So definitely your image will form at focus, and we already know the concave lens will always produce the virtual and erect image. And also we also know that the image formed by the concave lens will be smaller than the object. But when you will place the object at infinite, when your object at infinite, this time the image will be much smaller than the object, much smaller than the object. So you can note it down both the points, and no need to draw this. Okay, just note it down. First ray is like this, parallel to principal axis. Another ray is going towards the optical center. So you will use the rule for the concave lens, and accordingly you will draw the ray diagram. So in exam also, the examiner can ask you the ray diagram. Draw the ray diagram when the object is in between the optical center and infinity. So in this way you can draw the ray diagram. This is your principal axis. So there are only two cases for concave lens. For the image formation of concave lens, we have only two cases. Concave lens. And your heading is the formation of images by concave lens. So note it down. And, so this is your object, this is your image, and now complete this. So this is all about the image formation by the concave lens. There are only two cases we have. Rules you have to remember. The rules you have to remember, and accordingly you will draw the ray diagram. Written.
Yes, sir.
So now we will discuss the uses of concave lens. Okay, we'll discuss the uses of concave lens. So uses of concave lens means in spectacles. This is the spectacle. In spectacles, we will we use concave lens, and there are some optical instruments. Optical instruments you will study in the 12th class. You will have the physics in optics. There is in 12th class you will have the chapter optics, ray optics. There you will study the optical instruments like a telescope, microscope, and all that. So there we use concave lens, and in spectacle we use concave lens. So first use of this you can write use used in spectacles. Correct. Spectacle. This is spectacle. Okay. Correct. Effect of vision. So in human eye and the colorful world, we will discuss this defect of vision. And the second point, this is you also used in optical instrument. Used in optical instruments. Like telescope and microscope. Just write this. Copy this. The examiner can ask you give any two uses of concave lens. So you can write this. Written? Written? So now after this, we have the summary. Summary means, and this is your homework. This is a summary. Summary means in front of the concave lens, your object can be anywhere between the optical center and infinity. So this time the image will be between the optical center and the focus. We have already discussed that the size of the image will be diminished and the image will be virtual or erect. When your object will be infinite, your image will be at focus, hydro dimness, virtual or erect. And this is your homework. So no need to just copy this summary. You can write this homework. I'm giving you this homework. Okay. You already know, then no problem. But this is your, so just note it down, and we will then move to the lens formula for the concave lens and the magnification. Then so now I am moving to the lens formula and the magnification for the concave lens. So this is the lens formula. For the concave lens and the convex lens, you have the same lens formula. See this. And now what is the magnification? So magnification is also magnification is height of image divided by height of object, and this is also equal to position of image divided by the position of object. Position of image means image distance, you can say this, or object distance. Just write it down. Height of image at I means height of image. HO, height of object. And V and U, image distance. U is object distance from the optical center. All the distances we will measure from the optical center. Just write down the heading and lens formula and magnification of concave lens. So the lens formula and magnification is same for the concave and the convex lens. Done. So this formula and this formula you should know. And I am adding one more point. Uh, So if your magnification M is greater than 0, means your magnification is positive. If your magnification is positive, then uh, always your image will be virtual and erect. Image will be virtual and erect. In numerical, we will use this. And if your magnification is less than 1, what is the meaning of magnification less than 1? Means your this M is less than 1, means the ratio of height of image divided by height of object is less than 1. It means you can say the height of the object is greater than the height of the image. So you can say the image is diminished. You can say diminished image. And if your magnification is less than 0 or negative, then you can say your image will be real and inverted. If your magnification is greater than 1, then you can say uh, from this formula you can find out what will happen. This time this M will be greater than 1, means this ratio will be greater than 1, means height of image is greater than the height of object. So your image will be larger in size. So you can say a magnified image. These are very simple concepts. Magnified image. Okay, now please copy this, and this part is important also. We will use this in the numerical. I'm giving it 1 star. So the numerical, after this, we will solve the numerical. This week, I think this chapter will be finished. And from the next week, we will start the human eye and the colorful code. Human eye. And if you have any doubt, then you can ask me. And please try to repair your mic. Clear, Azaan? No, Azaan, just I am asking some of the questions. Uh, what? Just a minute. Is your mic working or not?
Yes, sir.
Your mic is not working. So in the next class we will. So Azaan, tell me which lens is a converging lens? Okay.
Con
Which lens is converging lens? Concave lens. तो देखना यहाँ ये concave lens है. This is the concave lens. You can see here. And rays are diverging here or converging? Concave lens is a diverging lens, not the converging lens. Converging lens is the convex lens. But this is not converging, this is diverging. Rays, you can see the actual path of the rays. But I know that now this is the right point. You have to differentiate. You have to differentiate, Azaan, between the mirror and between the lens. Both are opposite. Both are opposite. Okay. So this is the thing that you have to differentiate. Otherwise, you will get confused in the exam also. So in case of mirror, the thing is different. But in case of lens, the things are different. Okay, Azaan, so we will meet inshallah in the next class, and next class will be the next class. And I think this week we will finish this chapter. Okay. Okay, Azaan.